So today we are on 11th January. We are solving this problem of the day from Leetcode, that is maximal rectangle. So the question states, I will read the question in front of you. The question says that given a rows cross column binary matrix, it's a binary matrix contain only zeros and one, as we can see. Find the largest rectangle contain only ones and return its area. Now, what is the simplest thing? Area. If we add all of these ones, then it will be area. So finding the area is not a big part. Finding these ones, continual ones, and making a rectangle is the big part. So let's move to the board, writing pad, and then we will start this part. Okay. Okay. So here's this question, and so let me just take this. Yeah. Yeah. So what we are trying to do, what we will try to do is that we'll look this rectangle, or we'll look this binary matrix in a way so that we will first we need to find is the this rectangle. Okay, this rectangle is to be find. If we somehow, let's say I take example of 101, 101, 111. Okay, if you can see there are multiple rectangles over here. This is again a rectangle. This is a rectangle also. This is also a rectangle. Okay, if you can see properly, this rectangle has a height of 3 and a width of 1. Same for this part, but this rectangle has width of 3 but but height of, what is the height here? The height is 1 only. Okay, so we will try to find out this analogy, and we will use a method to find this area of rectangle. So what I am trying to do is I'll just make a prefix sum such that such that pre of I represents the width of rectangle. Okay, now we are clear on this part. So what we'll do is, let's say if I'm looking at this rectangle, if somehow I made it something like this, let's say I'm looking at the width, only width. I'm looking on the rectangle with height of only once only. So let's say the question is, you have to find the rectangles with the height 1 only. What you will do is just take the sum row wise. So you will see that this is a 1, then again 0. Okay, 1, 0 and 0. Again this is 1. So what is the area of this rectangle? 1, 2, and then 3. Similarly for this 1, 2, 3, 4, and 5, I can see that in this row I can make a maximum rectangle of size 5. Okay, that's good. Again in this I can make 1, 0, 0, and again here 1 and 0. So this is a prefix sum. This is a prefix sum. What is this? This is a prefix sum. Prefix sum when calculated row wise. But when we are calculating row wise, then this is a prefix sum. So first we will try to find this prefix sum. The next part is we'll go to each index. We'll go to each index. Let's say I'm that this index, and I will look in the top, in the bottom or top. I'll see ki how many rectangles, or what is the maximum amount of rectangle height I can take. Okay, let's say one here, one also, here one also, here one also. So if I'm going upward, I can make a rectangle of 1 and height 2 only. If I'm going downward, I can make a height of 1 and then 2 only. But I also need the, I have found the height for this part, that okay, this is the height, but I need a length, and the length should be the minimum, and the length should be a minimum. Why it should be minimum? Take the example of this section only. We have 10111 and 1111. Okay, let's say I'm standing at this part. If I will make this prefix sum array, it will look something like this: 1 2 3 4 and 5. And let's say if I'm standing right here, hmm, what I will do is I will take the width as 2 right now. Okay, then I will go downward. I'll check if there is a 1. Yes, there is 1. So height, I will increase the height to 2. Okay, And here the length is coming for 4, which is greater than 2. But the thing is, if I will take the length as 4, I have one sure thing that there will be some zero included if I take this rectangle of length 4 and height 2. So what I will do is I will iterate downward or vertically, and I will add on the height continuously if if ones are coming, else I will take the height as 1 only, and I will take the minimum of this vertical column, minimum of this the prefix sum that we have made, minimum of this prefix sum in the vertical iteration. Okay, for example, let me just reiterate to a new example. Let's say I have this 1101 111001 110111, let's say it's 0, and 001110. Okay, let's make the prefix sum 101201 123001 120120, and 00123 and 0. Okay, and let's say standing some point, let's say at this point. Okay, okay, now I got one thing for sure, that is uh, that the width of the rectangle right now is 2. I will iterate downward, I will iterate in the downward side, I will iterate in the downward side, I'll iterate in the downward side. What I will say is, okay, yes, there is coming 1. So I will increase my height from 1 to 2. Now my height has been changed to 2, but my width will be the minimum of w that was initial, and the prefix of I, the prefix of I, and the j. Okay, the prefix of ij. Okay, so I will take the minimum of this, and then what I will do is I will take my answer, the rectangle area, or the area of rectangle. My area of rectangle will be w multiplied by h. That's simple. And I will take the maximum of these. I will take the maximum of these answers, maximum of these answers as my final answer. I hope it's clear to everyone. The idea is fairly simple. First we will make a prefix, row-wise prefix, row-wise prefix sum, iterate column-wise, iterate column-wise, and the third part is we will iterate column-wise, uh, increase h plus plus if h plus plus if the the matrix of ij is equal to 1, is equal to 1, or else, and and we will take w as minimum of w, and the prefix of ij. Okay, and our answer will be maximum of answer comma height multiplied by width. And that's how we will get our answer. Let me show you the code, and I think you might have understood the logic that I'm trying to build here. And let's move to the code part. So first I have what I make this base cases, that if the matrix is empty, or let's say first row of matrix is empty, then again we will return the 0 0. Then the next is I have taken n and m as the size of matrix, the row size and column size. I have made this dp. Why does it why do what is the need of making this extra dp? Because here you can see the character is given. Okay, the character is given, and the mathematical operations, the plus minus will not be operable on this character matrix. That's why I am making this integer matrix. And then first I have made this the dp to this part. Like I have put out all of the values that are in being written as character in this matrix into dp as integer format. Then I have made it this prefix sum by using this simple logic. Then what I have done is I iterated to each of the element. And what I am doing, if I am standing at some element, let's say if I am standing at this one, I will iterate downward, and I will look into I will apply the logic of increasing the height and getting the minimum width in this column only. What This is what I have done. So int w is equal to dp of ij. This is a dp. Let's say I'm standing right here. If w is equal to 0, let's say w is equal to 0, then I will continue because this is not of our use. And the next part is int current w. We have current w is equal to w, and we will move from this I to downward till n. And if we will look also that whenever this value becomes 0, we will iterate till only that part, you know. And we will take the current width at the minimum, and we will increase the height in this format, and our answer will be submitted like this. So let's submit this answer and check the code. Yep, the answer is submitted. And okay, the thing is it is beating only 5%. Now the thing is I have looked into the further solutions, and they have used the stack operations to make this operation perfectly. And I'm trying to figure out why how I can use stack to find out. Basically, uh, if talking about the runtime operation, if I'm talking about the runtime operation, you can see that there is two loops that are going on from n to m. So there is a the possibility, or the time complexity is fairly simple of n cross m, but there is one more loop that is going inside it, you know. And that's why we need to, the time complexity will be something like this. The worst case time complexity will be of n square cross m, and that's why it is giving this much amount of runtime. I'm looking into the better solution, and if I find out why are they using stack and how they are using stack, then I will publish this solution also. So thank you, and see you tomorrow.